Okay, example 2. Find the volume of revolution when a finite region bounded by the curve. Let's take a look at this curve. And the two axes. Now remember that same idea as volume. Whenever we see a question, we will try as much as possible to sketch it, to know what exactly are we talking about when this what is this region that we're talking about. And second thing we need to note is, since it's to 3SF, we know that we don't have to integrate by hand. We will use our GC as much as possible. So first step, sketch the graph. Not difficult, just key in this entire thing into your GC here like this, and you get there. Alright, let me orientate you a bit. You're actually keying this in, and if you press graph, you will get something like that. It's not difficult to see that the region bounded is actually this particular region that over here. Of course, we can zoom in a little bit more. Let me say that this is -1, 2, and then you realize that this is the region we are talking about. Of course, it's flattened a little bit. Alright, so this is the region. Shading, it was not done by the GC, don't marvel at it. It's actually just for illustration. Okay, now what do we want to do? What is very important is this. What is the limit of the integration? We have to find the x-intercept. So let's go back. We go to second, calculate, and then 0, which is actually to find the intercept. Left bound, right bound, guess. Okay, very good. X equals to 1.5 here. So now we can safely say that, recall, volume is integrate pi y squared dx, because we rotate about the x-axis. What are the limits? 0 to 1.5, because this is 0 to 1.5. Can? So how do we do it? Obviously, we can enter this. Let's go back here again. We can go back to our GC. We could go back to our GC and say, oh, okay, easy lah. Alpha window, I know how to recall my integral sign. I say this is 0, 1.5, and I can attempt to type all these things in. Alright, and then you square it, etc., etc. You follow what I'm saying? I could have done that. That means I want to enter my, here. I want to enter this here. And y, obviously we all know what is y. I could have entered it, but let us look very carefully. We actually have done good work in entering y1 equals to this. Correct? So the calculator already know what is y1. Why don't we enter pi y1 square here? Where can we find the variable y1? We go to alpha, trace. Oh, you get y1. Oh, sorry, not 1. Sorry. Square. And the calculator actually knows what your y1 was that. Press enter. You get 24.7. Nice. Which is what we're talking about here. you get 24.7. Done. Okay, detailed instructions in the notes, not going to go through. But how do we present our working? Now, sketching the curve is always a good practice. Just have to put this as 1.5. How you get 1.5? Just by GC, don't need to elaborate. I just want to emphasize that you will present pi this expression square. Don't write y, not y, don't put y1 because the examiner would not know what is y1. But you must display understanding that you're actually substituting this expression in. And from here to here, from this line to this line by GC is obvious. No need to say anything.